excavation, you can also maybe think about using the excavated material again, or the earthworks again for a new project. So you see there's a lot of different kinds of possibilities how to think about this area of reducing and reusing, because there are a lot of options, as I mentioned. Still, if you look also at the levels of circularity, you have these 10 R's. I don't know if you're familiar with this, but just to put it in context regarding our use case, which deals with the reuse processes, we have here actually, as you see, use the product again as second-hand, or also refurbish, revive the product. So I'm going to show you what is meant by these two levels in our use case. So a closed loop in circular economy, what does it mean? It means a fully realized circular economy that emphasizes keeping goods products in use for as long as possible, and extending the lifespan through refurbishment, and therefore in a closed loop system. As you can see it here, you have a resource. This resource should be refurbished and again reused, then maybe it comes again to the end of life, and then it should be again introduced into the whole circle. So what does this reuse cycle actually entail? It entails, of course, going into the site or into the building which is going to be demolished or dismantled, and then assess what kind of materials and what kind of building components can be reused, for example, or recycled, which means it needs to be harvested from the building. Then you, of course, have to have some kind of data base built up on that, meaning, for example, how many windows are existing, what kind of structure is there, what kind of flooring, and so on. So you need to build up a database so you know how to proceed further. Then you have also to plan, in the sense, if the ideal case would be to include immediately after harvesting these elements and components into a new project, which is really difficult and happens very rarely, unfortunately still only in prototype projects. And then maybe also think about processing, meaning here, if you take windows and you want to use them again, they need to be refurbished, and you need, of course, some kind of warranty for that. So this is all really happening still very rarely, I must honestly say, concerning also at least in the European Union. So, for example, in the use case that I'm going to show you, there was a huge office building, as you see, of 15,000 square meters. It was constructed in the 80s, and I'm not going to read everything that's here on the slide, but as you see, there are large quantities, for example, of window panes, then parquet flooring, then different kinds of door frames, whatever. I mean, there was a huge amount of material, which actually also led one of our partners, materialnomaden, to start a company after being called to the building because there was so much material and so many building components. So I'm going to focus here now to show you the use case concerning parquet flooring. This it was done in this way. I'll show you also another figure here. What happened with materialnomaden, they were called actually to the building by the building owner. They needed to assess the building. Then they saw a large amount of parquet flooring, as I mentioned. They made some kind of database about that. And then they were thinking, okay, what is the next step? What can we do? And they actually got in touch with a manufacturer of parquet flooring. So they decided, because the wood was still good, but it needed to be refurbished. So they got into a contract with a manufacturer of parquet flooring who decided to do the refurbishing process and sell it again. So this was the only possibility actually to bring it to the market. So what we then decided, okay, we looked at the use case, and then we needed also to look at the main, let's say, processes that were happening. As you can see, for example, you have the manufacturer who has his own manufacturing process. You have the process of deconstruction, which meaning to commission the deconstruction, then also made, as I say, this kind of assessment in building and also the stock. And then you have one of the huge problems when you want to even recycle or reuse is how to transport the material from the building site, then again where to store it, and then again how to bring it to the market. So not to go too much into the detail, but you have here 3 companies that needed to collaborate together. The circular design company, this is our partner materialnomaden, as I said, then the manufacturer, and also of course the parquet floor layer, because if you call someone into the building to extract the parquet flooring, they need to know how, I mean, they need to be skilled and know how to do that. and it's very time consuming. It's actually also takes a lot of manpower to do that. So this is also one of the problems that you encounter when you think about, let's say, reusing certain elements. So how to combine this with blockchain, or how actually this technology could improve or help us. We had a framework already developed before, which you can see now in the other projects that I mentioned, where you see here that the framework is the main communication between the individual participants take place off-chain using peer-to-peer communication channels. The interaction with the blockchain is limited to commitments that represent irrevocable statements, and these need to be transparent and verifiable for everyone and are therefore stored on the blockchain. These statements include only a traction of the data that is held by the individual participant. What we did in our research here, we also introduced a zero-knowledge proof, which ensures the relation between the commitment and private data, as well as the correct execution of state updates. So what is actually zero-knowledge proof? It is an interaction between a prover and a verifier. So the prover's goal is to convince the verifier of the correctness of a computation without revealing the complete set of inputs. So it allows you an authentication and privacy protection in blockchain transactions, and also only a single message is here exchanged between the prover and the verifier with this zero-knowledge proof. So the framework utilizes here this, as I say, or it ensures the correctness of private processes on the blockchain. It allows also sending a transaction consisting of a reference to the message, to the message and the process state together with the zero-knowledge proof on the blockchain. Sorry, and the smart contract verifies here the correctness of the zero-knowledge proof and only updates the process state in case of success. Which means you have here transactions which are executed and actually have some kind of privacy in that sense. What does it mean here in our project? As you see, we have a BPNM choreography diagram for reparquet. So in the reparquet, you see you have, again, different kinds of stakeholders, different tasks happening between the stakeholders. And for example, here we have the extractor may complete the floor extracted task by sending a message to the refurbisher. Furthermore, although not shown in the figure, the value of extracted area needs to be smaller or equal to the floor area value that was provided by the material expert in the first track, which means it ensures actually that the tasks are executed as, let's say, agreed. So as a conclusion, I can say that when we apply the framework to the whole reparquet use case, it allows us to create a certificate of provenance. A reference to the state in the smart contract proves the validity of the certificate, as only conforming process updates can be submitted to the blockchain, and hence the claims of the certificates must be correct. So in the case of our reparquet, the certificate ensures that the amount of floor certified as recycled cannot exceed the amount identified by the expert. It also demonstrates here that this framework can be used for other supply chain, let's say, processes in the industry, and by adapting the approach, it becomes feasible to comply with privacy requirements and legislation while increasing the level of trust and security for digital processes in circular economy. So the future outlook could also be that not only would we like here to, let's say, have some kind of certificate verification concerning the process that everything has been executed as planned, but also we can think about generally CO2 certificates regarding the use of energy and CO2 emissions. So it would also be possible to, let's say, connect the CO2 emissions to tokens or product passports, of course, as already is happening, and in that way also align with the EU taxonomy. So thank you very much.